Hello, and thank you for coming to my Tech Talk. I would like to begin by thanking SingleSprout for sponsoring this talk. Today we will be discussing TypeScript. If you are a web developer, or really any kind of developer working in JavaScript, you've probably heard of TypeScript at this point. It's not something new, and it's sort of swiftly reaching the point of becoming a standard instead of the hot new thing. But for newer developers who have maybe just gotten a handle on vanilla JavaScript, Node, and React, the prospect of learning and working in TypeScript, or even the phrase static typing, might fill you with dread. So today we will explore TypeScript, and I hope to convince you that if you aren't working in TypeScript already, you should be. And if you are, there is so much more that you can learn and do with TypeScript to make your code awesome. This presentation, like all great stories, will have 3 acts in addition to a short prelude. Why is TypeScript, where we will explore some JavaScript history. What is TypeScript, where we will take a look at how it is used. How can I TypeScript? A few tips, best practices, and features that can help you get started with TypeScript right now. But first, do I have to? Obviously, I'm being a little tongue-in-cheek here, but it is an understandable question. Nobody wants to learn the new it thing just to see it go out of fashion. As most modern web developers will tell you, it can be exhausting keeping up with all of the hot new tools, libraries, frameworks, and languages that get developed and marketed to programmers. Some of them are awesome, a few are nice but niche, and an overwhelming number of them are simply reinventing the wheel. It's gotten so bad that many of us are skeptical when the new hotness comes along and declares itself king. But is TypeScript really all it's cracked up to be, and do I have to learn it? Well, yes it is, and yes, you do. Why? Well, for one thing, it's popular. TypeScript is being rapidly and overwhelmingly adopted, and while popularity is by no means a perfect indicator of the usefulness and soundness of a tool, the developer experience is overwhelmingly so positive, TypeScript shows no signs of going anywhere. It saves a huge amount of time debugging. While TypeScript requires more upfront work on your code, it has been demonstrated to reduce errors and debugging time in production code by up to 40%. That is an incredible amount of time saved that lets you do what you became a developer to do, develop cool new things. It'll increase your salary. Demand for TypeScript programmers increases as the suits catch on to the fact that TypeScript saves developers time and therefore saves the company money. The projected growth for TypeScript developers is 60%, higher than almost any other language on the market. The barrier to entry is incredibly low, and there are virtually no downsides. It is a superset of JavaScript, which means that all valid JavaScript that you write is already valid TypeScript. And as we will see later on, virtually every feature of TypeScript is optional. You have already been writing TypeScript, and you didn't even notice. So yes, you absolutely can and should learn TypeScript. It makes your code better, it saves your employer time, and therefore makes you more money. It is in high demand. TypeScript is awesome, and it is not going anywhere. This time, at least, it is good to be on the bandwagon. Above all, remember that learning new tricks as a developer is a rewarding experience, and it's why many of us are here in the first place. So you don't have to, you get to. So let's begin. Why is TypeScript? To understand the problem, you must understand what JavaScript is, what it isn't, and what it was intended for. So basically, JavaScript is a high-level, just-in-time compiled multi-paradigm scripting language with curly bracket syntax, dynamic typing, and prototype-based inheritance first-class functions. Easy enough, right? You got all that? No? Okay, well, let's just focus on dynamic typing and loose typing. If you've ever wondered why not a number is a number, and also not a number, why true plus true equals 2, why null is falsy but not false, or why an empty array is equal to an empty array preceded by a bang operator, you have loose typing to thank for much of that. JavaScript is loosely typed and will coerce type where it does not know what to do with a given value, which can cause some absolutely nightmare production code problems. Let's take an example. Here we see an example in the form of a function that doubles an input by adding it to itself with the addition operator. At a glance, and based off of the name alone, you might expect this function to multiply a number by 2, but if you pass it a string, it will still attempt to return an output. Think about how frustrating a bug like this would be to find in a large code base. And since there is no error warning, you would have to find it manually. Now you can begin to see where 40% time saving comes from. JavaScript needs stronger typing protections. So why doesn't it? A little bit of history can be very informative here. Brendan Eich created JavaScript in 1995 during a very short development period, and he was basically given free rein to make it as he saw fit, and with the express intent of being a scripting language for the browser. I fancy myself a pretty smart guy, but I don't know that I could create a programming language in a few days or even a few weeks and expect to make no mistakes, and Brendan Eich made plenty, not the least of which was loose typing and type coercion. As JavaScript grew in popularity with ES3 and later on Node.js, JavaScript grew to become a much more than a scripting language, and those mistakes Brendan Eich made back in the day started to really bother people. This quote here is from a draft of ES4, and it's worth noting a draft which did not really ever get fully implemented because of fierce debates among developers and major corporations about the future of ECMAScript. And you can see the push for strong typing way back then. In addition, while Node.js and ES6 provides module and import support, native vanilla JavaScript does not have direct support for modules or interfaces. Last, remember that JavaScript, despite all of the imported functionality of OOP syntactic sugar like class syntax, it is still fundamentally a scripting language that has been Frankensteined into usefulness as an object-oriented programming language. So what is TypeScript? What does it look like? What do you do with it? TypeScript was developed by Microsoft to bridge the gaps between ECMAScript and fully OOP programming paradigms like Java, primarily by providing support for optional strong typing. Remember that TypeScript is a superset of JavaScript, which means that all valid JavaScript is valid TypeScript. The relationship is similar to that between SCSS and CSS. It simply brings in some new tools and functionality that makes working with it easier. It is also designed to provide planned features from future JavaScript editions to current JavaScript engines. Note that TypeScript is not read by browsers or Node or really almost any environment, one notable exception being Dino. Instead, TypeScript is compiled into JavaScript at build time to a targeted JavaScript flavor such as ES5. And we'll talk about the compiler and its configuration shortly. So we all remember JavaScript 101 here, types, primitive types, structural types. Although some of the quirks of the language are showing here, for the purposes of writing TypeScript, it is important to note that when we talk about primitives, the lowercase word is important since, for example, capital N number and capital S string are their own special objects. And in most cases, you don't want to be making types with them. Static typing with variables and primitives looks like this. One of the things I notice when I talk to JavaScript developers who have not yet explored TypeScript is the fear that it's going to be a very tedious process to type literally everything. The good news is that, as you can see here, typing can be implicit and therefore completely painless. TypeScript knows that since foo has been initialized to a number, it cannot be a string unless you explicitly tell it that you want it to be reassignable to a string. If you want to allow looser typing for our friend foo here, you can assign foo a type when you declare it as any, which would allow it to encompass any type at all. Or you could specify that it can be a string or a number, which is a union type. Here we see an example of typing a function. X and Y, the parameters, are assigned the type number. And after the closing parentheses for parameters, we additionally have typed the output of the function. If we were to type the output here as a string instead, we would get feedback on line 3 indicating that our return statement is wrong. It's not returning a string. It's not doing what we think it should do. In the same way, if we were to try passing a string or Boolean value into POW when we call it, our IDE would highlight the incorrect arguments that we pass. So you can really start to see just how powerful TypeScript can be, how useful it can be in writing code. You know immediately as you compose and call your functions where the problem lies. Here, we explicitly create a type called myTuple. Tuples are not really thought of as their own data structure in vanilla JavaScript, although you will sometimes hear JavaScript developers refer to two-item arrays as a tuple. This is not really accurate. A tuple is a fixed-length array that has statically typed elements at each index. And they are all pretty common in strongly typed object-oriented programming languages. Here, each value we pass into the const array is appropriately typed because we type it with our own custom tuple type. If we relied on arrays like this in our application, it would be good to know that every index is of the appropriate type and that the array is not dropping necessary items. Similarly, with objects and classes, type assignments can be made explicit for each property on the object by using an interface, which can describe the shape of an object or a class. The class or object is then said to implement the stated interface. All this static typing allows for incredibly useful bit of functionality in your IDE, such as VS Code, by building out the features of IntelliSense for autofilling, syntax highlighting, and on-hover details as you continue to work your way through a code base. Note the void type on the delete methods typing on line 13, indicating in this case that void, that the method returns no value, on line 6 actually. Generic typing allows you to simplify abstract functionality that might accept multiple type shapes and constructions. This makes working with higher order functions very easy and flexible, but still strongly typed. Here we have two instances of the box class, A and B. One has the property contents that has been typed as a string because when we created the class, we told it that the contents would be of whatever type we pass into the constructor. You can also see in this example the use of optional parameters indicated by the question mark in the constructor's value parameter on line 3 and allowing us to explicitly allow for empty values within our functions and classes. Again, TypeScript is flexible enough that you can pick and choose how specific and how strong you want your typing to be. Browsers and the Node runtime still need JavaScript to run your code. So the compiler is where the magic happens. By running TSC and the name of the TypeScript file you are working with in the command line, TypeScript will generate a copy of your TS file and paste the compiled JavaScript version right beside it. By running the TSC command with the watch flag, the compiler will continuously watch your files and update the relevant JavaScript for you while you work. This makes switching between the two seamless. And now for part 3. Lastly, I have some tips and tricks worth picking up for those of you who are looking to explore TypeScript for the first time or who are maybe just getting started. First, a shout out is due to Basrat Ali Saeed. Several of these topics and tips come from his excellent deep dive into TypeScript, which is available for free online, and I highly recommend you check it out. Regardless of your experience level, it is an invaluable resource. My first piece of advice is to globally install the nightly version of the TypeScript compiler right now, which you get by appending the @next to the command as you see here. You can do this right now while you watch and forever hereafter, or for as long as TypeScript and NPM exist and you have a solid internet connection, you will have the latest version of TypeScript running on your machine. While in many cases as a developer, you would probably prefer to stick to the latest stable version of a given package, in the case of TypeScript, there is simply no good reason not to use the nightly version. The compiler only catches more bugs as time goes on, so it only becomes more functional and useful. If you add this line to your VS Code settings.json file by searching the VS Code command palette, your IDE will always know to have the latest version installed and running on its IntelliSense. Another common frustration I hear from developers new to TypeScript is working with NPM packages. Thankfully, an enormous monorepo exists where the TypeScript community has pooled together their work on creating type definitions for almost any reasonably popular package that you can think of. If you head over to npmjs.com and search @types, you can download them all. No reason to reinvent the wheel. Last, when starting out, it can be incredibly tempting, not to mention very easy, to use the AnyType liberally. This has the benefit of making the barrier to entry with TypeScript very low, but it can also stifle your learning. I strongly encourage everyone to use any sparingly. There is almost always a better choice, and taking the time to consider how you want your functions and classes working can unlock all the functionality that makes TypeScript so valuable and awesome. And it may just make you a better and more thoughtful JavaScript developer to boot. Thank you all so much for coming to this talk. And once again, thank you to SingleSprout for sponsoring this talk. And I will now open the floor to questions.
Cool. If there are any questions, just raise your virtual hand. Yeah, Tommy.
So you kind of hinted at it, but what was your particular experience like learning TypeScript?
Pretty easy, honestly. To be honest with you, the first few times I tried it, I would throw quite a lot into the code, which makes it very easy because you don't have to really think about it too much. But when you know that your function is always going to be returning a number, it's very easy to throw in a number and then see later on as the code base grows exactly where problems lie. Working with objects and something like React or other NPM packages can be a little bit more tricky and takes some getting used to, but it's remarkably fast. I mean, TypeScript is basically just JavaScript at the end of the day.
Nakami?
Thanks. So I'm just wondering, how would TypeScript work with something like React?
Yeah, it works remarkably well. A lot of that is due to the work of the community. The community has spent a lot of time creating types for packages and libraries like React. In the case of React specifically, if you're making a new React project, you can add a flag to the template to add TypeScript directly. If you want to add it to an existing React project, you can just npm install TypeScript and add in the necessary @types for React, for React DOM, for Node. It's pretty cool in React in particular because you can actually strongly type props, which makes your IDE highlight information about properties within functional components. So it becomes the process of passing props between functional components becomes very quick and painless because you know exactly what you're getting passed around.
Fascinating. Thank you.
Well, Roland, I saw your hand was raised. I don't know if you still have a question.
It was actually relating to React. I was curious about that. But actually, I am curious. This is coming from someone with near complete ignorance about TypeScript. Like, what do you mean when you're just talking about like people like an open source community is like making TypeScript accommodations for node modules? Like, I don't really understand why that would be necessary in the first place.
Totally. So like if you think about like importing in an object or something, I'm going to go back to an earlier slide here. Importing in some object that has methods and properties on it to use as a piece of a package in your functionality. Like if you wanted, say, the Lodash library to make working with large objects and arrays really easy. That functionality is going to need to be typed. Otherwise, TypeScript is going to throw a whole bunch of errors, and that might be a little bit frustrating to work with. But with the @types sort of mono repo, you can just npm install @types/Lodash. It'll download the type definitions for that library into your computer. And now, not only does your computer not throw those errors, not only is VS Code not going to throw a fit when you use Lodash, it's also going to autocomplete information for you and use IntelliSense to highlight how the functionality that you've just imported is going to work, what it's going to return inside your code. So actually, far from being inconvenient, it actually adds a lot of really awesome functionality to your IDE.
Cool. Thank you.
Yeah.
Yeah. Oh, Nakami, your hand went down. Are you also? Oh, okay, Nakami.
Yeah, it was. This is more of an opinion question. I'm considering that you have an app that is established already, but would like to have more features added. Would you recommend continuing on from that point using TypeScript or reformatting an app with TypeScript?
I would. The reason I say yes is because, again, so many of this functionality is optional. Even if TypeScript is throwing a whole bunch of errors in your code, it will still be compiled down to JavaScript when you run TSC. So those errors, you can just ignore them, or you can pick and choose which files you want. If you have, say, 100 files in a large application, you can change one of those files to be TypeScript and nothing else. So it's as low of a barrier to entry as you want it to be.
Great, thank you.
Sure.
Prasad, what's up? And then this will be our last question of the evening.
Sure. So my question is kind of a follow-up to Roland's question. So I'm completely not familiar with TypeScript. So you said for every library, there is like TypeScript, like a companion library that kind of decodes the data types. But does that mean that for every library that you have, you need kind of a companion library in your, like you need to have the import statements that you need to bring in basically for it to be compatible with TypeScript? Is that?
Yeah, I would say rather than compatibility, it's an issue of whether or not TypeScript is going to start informing your IDE that there are issues, that there's unclear data being passed around through functions. So it's not so much that it's not compatible with your code base, it's that if, say, you use an extremely far off and away NPM package that like 2 people have downloaded ever, if it's something super niche and no types exist for that, you're either going to want to write those types yourself so that you know that your functions are taking and returning the values that you expect, or you're going to want to ignore those errors. That can be a bit tricky in a larger code base. That might be one of the only cases in which I would say maybe don't use TypeScript if you're using a super niche NPM package and it's your entire application depends on it. But also maybe type it out yourself and submit it as an NPM package so that the person who comes after you can use it and have an easier time.
Sounds good. Thank you.
Absolutely.
All right. Thank you, Graham. Let's give Graham one last round of applause.
Incredible.
Yeah.